Which other points do we have for group 4? What about the oxidation states? They have variable oxidation states. They have oxidation states. Why am I writing this in black? Let's leave it. They have oxidation states of +1 in dinitrogen 1 oxide, for example, right? Of +2 in nitrogen 2 oxide, right? Of +4 in nitrogen 4 oxide, right? Of +5 in phosphorus 5 oxide. P2, sorry. That's P2O5. So you can see the oxidation states they have. +1, +2, +3, and +5. They have these oxidation states. Alright? Now, what about, remember for group 3 we said that group 3 elements are used for doping, right? To form p-type semiconductors. Now what happens here? These guys, group 5 elements are used. Now that is the non or the semi-metallic group of group 5. And what are the semi-metallic group of group 5? We have arsenic and we have antimony. Arsenic and antimony are used for doping. Or even, arsenic and antimony majorly are used for doping to produce or to form. They do not necessarily produce an N-type semiconductor. To form an N-type semiconductor. So what does this mean? You know, group 5 elements have 5 valence electrons, right? Okay, I will explain it with these 7 points. How do they ionize? They ionize by gain of 3 electrons. Ionize by gain of 3 electrons to form. Ionize by gain of 3 electrons to form a tri-negatively charged ion. A tri-negatively charged ion. And how do we explain that? Please, let's take a look at this. Let's take a look at this. Nitrogen here, right, ionizes. Nitrogen ionizes by gain of 3 electrons to form that, right? Although nitrogen does not exist as N in nature, right? So what do we do? To balance that, we have N2 plus 6A minus to give us 2N3 minus. And this is balanced. Now, what this tells us is that being group 5 elements, they have 5 outermost electrons and need 3 more electrons to form a stable octet, right? So you can see that it gains 3 electrons to form an anion. And what kind of anion is this? It's a tri-negatively charged anion. The same thing happens for phosphorus, right? Phosphorus is monoatomic, gains 3 electrons to form that, okay? To form that, although you can form different ions of that, but on the average, that is what you have, right? So because they form negatively charged ions, they are used to make a negative type semiconductor, as you can see. So that is what we mean by N-type semiconductor in statement 6, that they are used for doping to form an N-type semiconductor. So what you do is you dope tetravalent semiconductors as group 4 semiconductors, majorly germanium. You dope germanium with either arsenic or antimony. And then what happens? You make germanium N-type, having more electrons than O's, right? So you see, it gains electrons and it becomes an N-type semiconductor. Very important. What is used for P-type semiconductor again? Group 3. What is it for n-type? Group 5. And that's it. Now what about group 8? Statement. Which other factors do we have here? What can we say about the oxidizing ability? Now they are not reducing agents. Instead, they are oxidizing. Okay? Because now they are gaining electrons. So they are oxidizing agents. Because they themselves are reduced in chemical reactions. They are good oxidizing agents. They are good oxidizing agents, as seen. Alright? So they are good oxidizing agents. We'll compare them to groups 6 and group 7 as we move on with our lecture. So they are very good oxidizing agents because they gain electrons. Alright. So guys, that's it mostly about that. I believe you know that nitrogen, being the first member, is found in the atmosphere. About 78% of air comprises nitrogen. Now it tells you how important they are. Phosphorus is used in the production of fertilizers and other important chemicals. Arsenic and antimony are used for doping of semiconductors. Okay, so these are important uses of the group 5 elements. Thank you for sticking with us. I hope it made sense. And it's also important for us to state that they are p-block elements, right? Because you know, when you take the electronic configuration of these atoms, especially nitrogen, phosphorus that we're familiar with, nitrogen has an atomic number of 7, which is 1s2, 2s2, and 2p3, right? So it means the final electrons fall on the p orbital, making it a p-block element. So these guys are p-block elements, right? And it shows, it is so because the last electrons fall on the p orbitals. So guys, thank you for sticking with us. We appreciate your time and efforts. Do well to join us in the next lecture when we talk about group 6.